For today's lesson, and in fact for this unit, our focus standard continues to be from grade 8, Expressions and Equations, Standard C, Analyze and Solve Linear Equations. Our topic is still from Simplifying and Solving Equations, and today's lesson is more practice simplifying algebraic expressions with algebra tiles. Our essential question is, how do we use the distributive property and combining like terms to simplify algebraic expressions? So we're keeping the same essential question as our last video lesson to do 2 more example problems. Let's go ahead and get started. Please make sure, though, before you do, that you have your question column and your note column set up. So we're going to go ahead and just review the 2 steps that we've been using to simplify algebraic expressions. And our first step is to get all the tiles into the positive region of the mat, and we're relating this to the distributive property. And so anything that's down below is going to get flipped up, and anytime we cross that dotted line into the next region, it changes the sign of the tile. So it went from positive to negative. If these were negative and we flipped it up, then it would go to positive. And then we're also looking to combine like terms and remove all 0 pairs. So anywhere where we can find equal opposites, a positive and a negative of the same type of term, then we are going to remove those off of the mat. So let's go ahead and get started with our first example. So here in example 1, I've given you the expression 2x squared minus the quantity negative y squared plus x squared plus 2 plus 4. So we're going to do this in a few steps. First, we want to draw onto our algebra mat the tiles that are going to represent this expression. And so remember, anything where we have a negative outside of the parentheses tells us that anything inside of this parentheses is going to get copied down into the negative region, or the opposite of region. We have a few names for that. And then anything outside of the parentheses gets copied into the positive region. So go ahead and pause the video here and see if you can sketch in what you think the tiles are going to look like that represent this expression, and then resume the video to check your work with mine. So let's go ahead and see how you did. So for starters, we have 2x squared terms, so that's our 2 teal terms, and you can kind of see there that they say x squared. And then we're in the negative region, or the opposite of region, and inside there we should have a negative y squared, a positive x squared, and 2 unit tiles. And then back up in the positive region, because we're outside of those parentheses, we're going to have positive 4 unit tiles. So this is pretty much what your mat should look like with these tiles. And then do you remember what this is about? This is our first step. So we want to take anything that is in the negative region, and we want to flip it into the positive region. So what are we going to have left when we do that? Go ahead and draw in the next step. Hopefully you remember that when you flip over that dotted line, it changes the sign. So we still have 2x squared and 4 positives. But now this negative y squared became a positive y squared. The positive x squared became a negative x squared. And the 2 positive unit tiles flipped over to become 2 negative unit tiles. So now we're seeing that they are removing 0 pairs. So if we remove those 0 pairs, a positive x squared and a negative x squared, those are going to combine to make 0, so they go away. And 2 unit positive 2 and a negative 2 are going to combine and go away. So what do we have left? And I guess before we get there, we should talk about our expression. What is this before we remove our 0 pairs? So we have 2x squared tiles, a positive y squared tile, a negative x squared tile, 2 negative unit tiles, and 4 positive unit tiles. So you should have these terms. You may not have them in the exact same order as I do. There's a few things that may get moved around, but the terms should be the same. You should have 1, 2, 3, 4, 5 terms. 3 of them have squares on them, and 2 constants. So now, after we remove those 0 pairs, what's our mat going to look like next? Should look like this. So go ahead and write, now that we have fully simplified it, we've flipped everything into the positive region, we've removed all 0 pairs, what is our final simplified expression? Should have something like x squared plus y squared, because both of those are positive, plus 2. These two terms could be switched around. You may have y squared plus x squared plus 2, and that would be okay. But the constant term of 2 should be at the end. Alright, let's try one more example. So here we have example 2. Here is your expression. The negative of the quantity 3y minus xy plus 1, close parentheses, plus y squared plus 2y plus 2xy plus 2. So I'm going to ask you to take a moment, pausing the video if you need to, and see if you can set this expression up with algebra tiles on your mat. And then resume the video to check your work with mine. Let's see how you did. So in this negative or opposite of region, we should have 3 y tiles, a negative xy tile, and 1 positive unit tile. And then up above we have a y squared tile, we have 2 positive y tiles, 2 positive xy tiles, and 2 unit tiles. So this is what pretty much what our board should look like when we draw in those tiles. And then what's our next step? What do we need to do to get to our next step? Pause the video here and see if you can draw in what our next step is going to be, and resume the video to see if we agree. Alright, you said that we needed to take all of these tiles that are down in the negative region and flip them up. I would agree with you, and here's what that would look like. So we still have all these tiles up here that were in the top, but now these 3 positive y tiles flipped up to be 3 negative y tiles. This negative xy tile flipped up to be a positive xy tile, and this positive unit tile flipped up to be a negative unit tile. So we flipped everything up into the positive region. And so if we were to write our expression for this, what would it be? Go ahead and write that expression in. So here's how I wrote it. I have a positive y squared, 2 positive y's, 2 positive xy's, negative 3y, another positive xy term, 2 positive unit tiles, and a negative unit tile. So what's our next step? Go ahead and draw in on our mat what we're going to look for and do next. And then if you want to go ahead and try and simplify it further on our mat, go ahead and do so. And then resume the video to check your work with mine. So it should start to look something like this, where you're finding 0 pairs, equal opposites. So here I have 2 positive y's and 2 negative y's. Those make a 0 pair and will come off. And so will a positive and negative unit tile. So I can circle those and say I'm going to pull those off. And when I do, what do I end up with? What's left is our positive y squared, 1 negative y tile, our 3 positive xy tiles, and a unit tile. So let's go ahead and write that as a simplified expression. So we'll have something like y squared minus y plus 3xy plus 1. And this would be as simplified as we can get. All terms have been combined, and all zero pairs have been simplified. And we've gotten everything into the top region, meaning we got rid of parentheses using the distributive property. So this would be our final answer. And so that's going to wrap up our video here. Please make sure that your notes are complete, and we'll continue to practice solving equations, simplifying expressions in class.